All right, hello and welcome to the next online class of the day. I'm James. Today we're talking about space science. And as you can see, I completed the space helmet that we started building together in yesterday's class. It still catches on my glasses a little bit there. We just had the frame done when we ended off yesterday, and I've done quite a bit. I put some cardboard along the back, and then I just covered everything with duct tape. There's really nothing difficult about that. It just took some time, nothing really special. I just covered everything in duct tape. And then I found a 2-liter soda bottle and cleaned that out, cut it up, and it just happened to fit nicely over here. I've added some patches. I just printed these out with a color printer and cut them, and I just pasted them on there. I just glued them on there. We have the NASA logo. I added the Apollo 11 mission patch. That's the first mission that landed on the moon. Then on this side, again, the NASA logo and the American flag. And on astronaut outfits and stuff like that, this is how they have the flag. They have it pointing this way because it shows if you're holding the flag and moving forward, that's how the flag would look from that angle. So moving forward. Well, we have some great stuff in store today. We're going to be talking about planets in our solar system, and I'm really excited to get into that. For those of you who were watching the first round of these online classes back in the spring, some of this is going to be familiar material to you. But we have a lot of new people here today, and it's great to go over this stuff a couple of different times. You're going to pick up something new every time. You're going to learn something more every time you study something. We do have some people that sent in photos of helmets that they made after our class yesterday. On the left there's Hadia from Pakistan, and she made that great looking helmet there. And Hadia, I'm curious what you used for your faceplate. I used, again, it was like a soda bottle, but your mask seems clearer than mine. It's got less obstructing your view. I like that a lot. Ripping patches off of my helmet. I'll have to glue that back on. And there we have Riley from Texas, and you can see she's well on the way with her own helmet there. All right. Coming up later today is going to be a launch from SpaceX, and we covered last week what goes on leading up to a space launch. And if you want to watch a live webcast of something that's happening in real time, you can use this link, spacex.com/launches. It'll take you to this page that SpaceX and NASA have, and there's a link directly to the live stream. It's going to be this afternoon. What time? Let's see. It says exactly what time. 3:55 p.m. Eastern Daylight Time. So it's about 12. 12:55 Pacific Time is when that will be launching. So if you want to tune in and watch that later today, I suggest it. It's very educational. There's a whole timeline of leading up to the launch, everything that they do, and a timeline after the launch, timed down to the second of what happens. A lot of fun. All right, so we're talking about planets of our solar system, but not just the planets. There's more going on in our solar system than just the 8 planets. So I also call this planets and stuff of our solar system because I feel like that's more accurate. All right, I am popping into the Q&A section. Here is Cosmo the Cosmonaut. Hello, Cosmo. And Alette and Aubrey and April and Lorenzo. And yes, April, we are on the moon. You can see from our background here. I found this great new background. It's here we are on the moon. There's Earth. I can almost see my house from here. Just be right up there. We can see, let's see, looking backwards here, there's Texas, there's Florida. Hi, everyone. Okay, good. Well, we're not going to talk about the sun. That would be a completely separate subject. That's at the center of the solar system. Everything orbits around that. First planet from the sun is Mercury. And this is what Mercury looks like. Nope, that's not a picture of the moon. That's a picture of Mercury. There's a picture of the moon and Mercury. So over here on the right side of the screen is the moon. And here in the middle is Mercury, what Mercury would look like if it were in our night sky at the same location as the moon, the same distance from our planet as the moon. And you can see it's barely bigger than the moon. It's not a super huge planet. It's named after, in Roman mythology, Mercury is the god of commerce and travel and thievery. And he's the Roman counterpart of the Greek god named Hermes, the messenger of the gods. And they probably named this planet Mercury because it moves so quickly across the sky. It's moving quick, it's running messages back and forth between the different gods or the different planets. I think it's a great name for it, very fitting. It's a small planet. It's only 3,000 miles across. It gets really hot there and it gets really cold because it has no atmosphere. So on the night side of the planet, it's going to be negative 170 degrees Celsius. And on the day side of the planet, it's going to be 350 degrees Celsius. Huge temperature difference, hundreds of degrees difference just between night and day. No atmosphere means no chance for the planet to transfer that and exchange that heat around and make it more equal around the planet. It's only 58 million kilometers from the sun, very close. You'll see this term here, AU. AU stands for astronomical unit. That is a unit of measurement that we use to measure stuff, particularly within our solar system. And 1 AU is the distance from the sun to the earth, about 93 million miles, if I am remembering that correctly. I will fact check myself in just a few slides when we talk about the earth. So it is 0.38 AU. So it's about 1/3 the distance from the sun to the earth. Okay. Its rotation period, it rotates around itself every 58.6 Earth days, and it orbits the sun every 88 Earth days. It's a small planet, 0.38 G. 1 G is the gravity that we feel here on Earth. Stand up, jump around, you feel the amount that you're being pulled back to the planet. That is 1 G, 1 gravity. Mercury has almost 1/3 of that. So you would be bouncing around on the surface of Mercury. And while you were doing that, you would either be super hot or super cold and you would have no air to breathe. So I hope you are wearing a space helmet and a spacesuit. All right. So it rotates once every about 59 Earth days. And that rotation is slower than that of every other planet in the solar system except for Venus. Due to the planet's slow rotation on its axis and its rapid movement around the sun, a day on Mercury lasts 176 Earth days. So you see the sunrise, and in 176 Earth days, you're going to get your next sunrise. That's weird and cool. I like it. All right. Oh, April's saying that she can't hear me very well. I hope others can hear me. Let me adjust something on my audio settings. I hope that should make a difference. Okay, good. Oh, and Ash is asking, where do you send the picture for the helmets? Yes. Just one moment. Let me see if I added that in a slide at the end. I'm going to pop out of this really quick. You get a sneak peek at everything else here. Oh, I need to get rid of that. That promo code is no longer valid. Okay. events@delphian.org. This is the email address that you can send photos of your helmets to. And everyone else that sends me photos, I will show them on, I think it's Thursday or Friday, that our next online class for space sciences, and I'll show it then. I'm going to leave this up there for just a moment. I'm going to move on with the slideshow, and I'll show it again right at the very end. Okay. We have a lot of slides, so let's see if I can get through it all today. All right, next planet, second planet from the sun is going to be Venus. Here's a picture of Venus. Very cloudy, very, very cloudy. Very thick cloud layer on that. You can't see the surface at all. If Venus were as far away from the Earth as our moon is, that's what it would look like. That's how big it would be. and it'll be pretty bright in our night sky. Venus is incredibly bright. It bounces a lot of sunlight off. It's named after the Roman goddess of love and beauty, and it's called Earth's sister planet because it's almost the exact same size as Earth. It's only about 1,000 kilometers smaller in diameter than the Earth, and it's about the same level of gravity. It's 0.91 Gs. So it's like 90% of Earth gravity, pretty close to us. That's about where the similarities end. That's as far as you could go in calling it a sister planet, because the temperatures on the coldest day on the surface of Venus on the night side of the North Pole, it's going to be 50 degrees Fahrenheit. That's as cold as it gets there. The rest of the planet is super hot. It can get up to 900 degrees Fahrenheit. If you were to take a large pizza, which I would, and put it on the surface of Venus, it would be fully cooked in, I used to know this off the top of my head, something like 10 seconds or something like that, 10 seconds, and then it would be burned at 11 seconds. So you got to eat it at that perfect, you got to find that right time to eat an entire large pizza before it burns. It is 108 million kilometers, or 0.72 astronomical units. So it's, a little bit more than 2/3 the distance from the sun to the Earth. Its rotation is weird. So its rotation period is 243 Earth days, and its orbital period, the amount of time it takes to orbit the sun, is 225 Earth days. So if you're doing the math, you're right. Its day is longer than its year. So that's weird. And it also rotates from east to west, not west to east. Yeah, anyway, opposite of how it is on Earth. I put these slides together, so if I mix that up, then that's my error. But Earth rotates this way, Venus rotates this way. Super weird. So the sun would rise in the west and set in the east on Venus. And you would be burning up because it's super hot there. It also has an extremely dense atmosphere. The air is very thick. It is 90 times more dense than Earth's atmosphere. So because of this dense atmosphere, it traps more of the sun's heat than any other planet in the solar system. And that's why its surface temperature is higher than Mercury, even though Mercury is much closer to the sun than Venus. Thick clouds going to trap that heat. Okay, next I think we're talking about Earth, but I'm also, let's see. Great, good. People can hear me now. Excellent. All right, now time for my favorite planet, Earth. Yes, hello, home. We are, 12,800 kilometers in diameter. Surface temperature from -69 degrees to Celsius up to 58 degrees Celsius. That's about 136 degrees Fahrenheit. We are 1 astronomical unit from the sun because we made up the terms of measurement. So it's all about us. 24 Earth days is our rotation period. 24 Earth hours is our rotation period. 1 moon, 1 G of gravity. Pretty great place. Someone was asking, where does the name Earth come from? It's the only planet that doesn't get its name from Greek or Roman mythology, at least not in English. All these names, I'm just talking about the English names for these things. Earth comes from the Old English word Eorth. I assume I'm pronouncing that correctly, which means ground. In German, it's called Erd. Latin is terra. Spanish is tierra. Swedish is jord. And the ancient Greeks called it Gaia. Everyone's got their own name for it. Every language came up with its own thing. And I think that's awesome. So Earth, some cool things about Earth. It has life. That's pretty cool. It's the only place in the solar system that you can get a decent piece of pizza. And it's the only place in the solar system where you have a chance of being attacked by a bear. And if you don't believe me, here's a handy chart to help determine where you have a risk of bear attack in our solar system. And you can see that per this highly technical chart here, Earth is the only place that you could be attacked by a bear. The moon. All right, so we called it the moon singular thing, a one thing, because until 1610, we didn't even know that there were other moons around other planets in our solar system. Galileo found 4 of them around Jupiter in 1610, and that kind of changed everything about how we thought about our solar system. The moon, like the Earth, has different names in different languages. In Latin, it's called Luna, and in Greek, it's called Selene, who is the goddess of the moon in Greek mythology. Our moon is small. It's only 3,400 kilometers in diameter, just a little bit smaller than Mercury. And like Mercury, it can get really cold or really hot, depending on if you're standing in the sunshine or not. It can get up to 111 degrees Celsius, 232 degrees Fahrenheit. Definitely hot enough to boil water. Or, so that's in the sunshine, or negative 171 degrees Celsius if you're in the shade. It is about 1/6 of Earth's gravity. So if you've seen any videos of astronauts on the moon and they're kind of bouncing around, they weigh 1/6 as much up there as they do down here. So the moon rotates once every 27.32 days. Rounded up to 28 days, rounded down to 27 days, but that's fine, it works. It also revolves around the Earth once every 27.23 days. It rotates at the exact same speed or frequency that it orbits the Earth. So that means that only one side of the moon ever faces the Earth. With your own 2 eyes, unless you have gone up on a rocket and gone around the backside of the moon, you have only ever seen one side of the moon with your own eyes. We have pictures of the far side, but it's what's called tidally locked, or in tidal lock with Earth. It rotates at the exact same frequency that it orbits. Keep that term in mind. We're learning that word newly here. For some of us, it's the first time. We're going to use that a lot when talking about other moons around other planets in the solar system. The moon is not made of cheese. That's important. Mars. Aside from Earth, this is my favorite planet. Mars is not as big as I once thought it was. In my mind, it was pretty much the same size and everything as Earth. Nope, it's much smaller than Earth. It's bigger than our moon, though. This is what Mars would look like if it were in the night sky at the same distance from Earth as the moon. It's about 6,800 kilometers wide. Surface temperature, it can go as low as negative 140 degrees Celsius, very cold, or it can get up to 20 degrees Celsius. I think the highest recorded temperature was even higher than that. So that's about 60 degrees Fahrenheit. I think they recorded in the middle of summer on the equator on Mars one time, something around 70 degrees Fahrenheit. That's pretty great. You know, that's human temperatures. We can do that. It's a bit farther from the sun than the Earth is. It's 1.52 AU. So it's 1.5 times the distance from the sun as the Earth. Its rotation period is 24 hours and 37 minutes. That sounds like an Earth day to me, very close. Martian days are called sols, S-O-L, sol. So one sol is 24 Earth hours and 37 Earth minutes. And there's teams of scientists that work at NASA and different organizations that have rovers and different machines on Mars that they're operating. And they don't operate on Earth time. They operate on Martian time. So sometimes their workday will be, you know, an average Earth workday. And sometimes it's in the middle of the night because it shifts by 37 minutes each day. Its year is very different than the Earth year. It is 687 Earth days for it to orbit the sun. It has 2 moons, which we're going to learn about in a little bit. And gravity is weaker than Earth's. It's about 1/3 of the gravity on Earth. So it's named after the Roman god of war. It's a very red planet. The Romans thought it looked like it was bloody. You can see the connection there. And in Roman mythology, Mars, the god of Mars, rode a chariot pulled by two horses named Phobos and Deimos, meaning fear and panic. So the two small moons that Mars has are called Phobos and Deimos, named after those two mythical horses. It has an atmosphere. It does. It has air, but it's only 1/100th as dense as Earth's atmosphere. Very, very thin atmosphere. The sky, here on Earth, you look up at the sky and the sky is blue, and at sunrise and sunset, it can look reddish off at the horizon and stuff like that. It's the opposite on Mars. The sky naturally has a red color to our eyes, and at sunrise and sunset, the horizon looks blue. That's weird. That's cool. I like that. Scientists have confirmed that 1 billion years ago or more, there was liquid water on the surface of Mars. They know that at least some of that water, or maybe most of it, was salty, like our oceans, maybe even saltier than our oceans. They don't know if there was fresh water. They're still trying to figure that out. There's a lot of good science to do on Mars. All right, I'm gonna pop in the Q&A real quick before we move on to Jupiter. Make sure I am not ignoring anyone's questions here. Didn't you use these slides in a different webinar? Yes, Alette. I am using these slides. Many of these slides are the same. I've updated some of them from a class that we did. It's been a few months now. So I figured, hey, it's good to go over this stuff again, because even as I was going over these slides in preparation for this webinar today, I was learning new stuff and like checking, wait, did I get that number correct? Oh, and I actually updated and fixed a few things. All right, Shanna says Sol is the Spanish name for sun. Oh, yes, thank you. Milo is asking, are there any planets that are also tidally locked, that are rotating at the same frequency that they orbit the sun? There are no tidally locked planets, not in our solar system. There are in other solar systems around other stars. We can talk about that in a different class, but none here in our solar system yet. I would think that the first one that would get tidally locked is Mercury, because it's small, it's the smallest, and it's the closest to the sun. So it's the one that's getting pushed around by the sun's forces and the sun's gravity more than anything else. All right. Good. April says that Jupiter is her favorite planet. Great. Oh, Evan's asking about the next possible planet past Neptune. All right, I am going to speed up so we can get through all this and talk about this theoretical 9th planet out past Neptune. Here's Jupiter. That's gorgeous. And massive, 138 kilometers in diameter. That's huge. Surface temperature. It can get really cold, 163 degrees Celsius, or it can get really also still cold, negative 121 degrees Celsius. That's just cold. It's just a cold planet. It is 5.2 AU from the sun. So it's from the sun to the earth times 5 plus a little bit. Its rotation is really quick, 9 hours and 55 minutes. It rotates, 2-3 times every Earth day. That's quick. It's really quick. But it takes 12 Earth years for it to orbit the sun. We're getting pretty far out there, so it takes some time to travel that distance. And its gravity is 2.4 G. So if you were standing on the surface of Jupiter, it's a gas planet, so you can't really stand there. But you would be experiencing 2.5 times your weight. Maybe a great place to work out. It has 79 moons, 79 known moons. Tomorrow they could discover another 2 or 3, and I'd have to update that number. Yeah. If Jupiter were in our sky at the same distance that the moon is, that's how big it would look. That would be weird and cool. Wouldn't that be awesome to look up in the night sky and see Jupiter up there like that? That'd be amazing. Jupiter is named after the king of the gods in Roman mythology, which makes sense. It's the king of the planets. It's by far the largest one. Saturn's also big, but it's not Jupiter big. Jupiter, like Saturn, has rings, but you can't see them. They're very dark, and that makes them very hard to see. They're made of dust that have been kicked up when its moons are hit by meteors. And those rings aren't going to last forever. They might last a few million years, tens of millions of years, but eventually they'll either get, they'll disperse and just kind of like fade away, or they'll get pulled, the material will get pulled down into Jupiter itself. Here are 4 of the most important, or the most well-known moons of Jupiter, and their relative size compared to the Earth and compared to our moon. Here you can see Io is pretty similar to the size of our moon there. Europa is a little bit smaller. Ganymede and Callisto are both larger than our own moon. I think I have some slides here about each one. Yeah, we're going to talk a little bit. I have time. I'm going quick today. We're going to talk a little bit about those 4 large moons of Jupiter. Io, it's cold, negative 163 degrees Celsius. Its rotation period, it is tidally locked with Jupiter, which means only one side of it ever faces that planet. And it orbits Jupiter every 1.769 Earth days. Every 1.8 Earth days, it orbits Jupiter. So it also rotates every 1.8 Earth days. Its gravity is very weak compared to what we would consider comfortable. It's 0.18 Gs. But yeah, that's a real picture, by the way. That's not an artist going in and adding colors. That's not scientists adding a bunch of colors so they can see different things. No, that's the real color of Io. There's a lot of different minerals and metals that have been kicked up on the surface of it that create these really cool colors. Here is a drawing, an artist's idea of what standing on the surface of Io might look like looking up at Jupiter. You can see there's volcanoes on Io, lots of volcanoes. Because it's so close to Jupiter, the gravity of Jupiter is constantly squeezing and pulling the moon. And if you take your hands and you put them together, and you start rubbing them, it doesn't take very long. You start feeling heat. And if you were to take something like a rubber squishy ball or something like that, like one of those stress relief balls, and you were to squeeze it and squeeze it and squeeze it and squeeze it, it would start to heat up, because that friction is creating heat. That's what's happening on Io, and it creates these active volcanoes. Europa, okay, so also small compared to Earth, a little bit smaller than our own moon, still very cold. Oh, it looks like I forgot to do the math on how many Fahrenheit is negative 171 degrees Celsius. It's also tidally locked with Jupiter, and it orbits Jupiter every 3.5 Earth days. This is what it would look like possibly on the surface of Europa, looking at Jupiter. So the surface of Europa is water ice. It's ice. And they believe that maybe 100 kilometers below that thick crust of ice, that there is a liquid ocean. So it's thought that the tidal effects, meaning, that push-pull of Jupiter pushing and pulling on that moon, are generating heat, much like on Io, and keeping that water liquid deep under the surface there, keeping it nice and warm. There is twice as much water on Europa as there is on Earth. Take all of the rivers, all the lakes, all the streams, all the seas, all the oceans of Earth, combine it. Now double it. That's how much water is on Europa. It's a lot. That's really cool. Scientists think that if there is life in our solar system, the most likely place is maybe Mars. They're looking. Maybe Europa. Liquid water seems to be pretty important for life as we know it. So let's look where there's liquid water. Here's Ganymede. Gorgeous. Look at that. It's such a gorgeous moon. It's a bit bigger than the other ones. Still, it's going to be super cold. Still, the gravity's not going to be a ton because it's not as big as Earth. It is also tidally locked with Jupiter, but it's a little bit farther away. It orbits every 7 Earth days, 7 and a little bit Earth days. Here is an image of what it might look like standing on the surface of Ganymede. This is a picture from the TV show The Expanse. Okay. Evan's wondering if people could adapt to live on other planets. Definitely. We would adapt with technology first. I don't know how we would adapt the human body to live on the surface of Mars without a lot of help. It's just a lot different. The air is so thin. We would really need a lot of adaptation in order to survive that. Same thing on the surface of Venus. Too much pressure, too intense, too much heat, too much everything pressing. Your body would just get squished. But again, with technology, you can adapt to a lot of different things. Ethan is asking, how hot is a neutron star? We can cover that in another webinar, maybe next week. We'll talk about different kinds of stars. Super hot, hundreds of millions of degrees. I think that's about how hot the surface of a neutron star is. Hundreds of millions, super hot. The surface of our own sun is only a few thousand degrees Celsius. Neutron stars are much, much hotter than that. Okay, good. Someone is asking, when does the webinar end? We're officially scheduled to go through 11:45 today, but there's no one coming up immediately after this. So if we need to run a little bit long, I will. We're scheduled to end at 11:45. So Ganymede is 8% larger than Mercury, and it has more than twice the mass of the Earth's moon. It's twice as heavy as the Earth's moon. So if Ganymede was orbiting the sun instead of orbiting Jupiter, it would be a planet. It's bigger than Mercury. Scientists believe that there also is a large saltwater ocean under the surface of Ganymede. They think about 124 miles below the surface. And I read that, and I think that's a very specific number. There must be some piece of evidence that they're like, yeah, 124 miles, not 125, not 123. This article I was reading said about 124. They know what they're talking about. So I'll go with that. Here's Callisto. This is also tidally locked with Jupiter, as with all its other moons, and it orbits Jupiter every 16.7 Earth days. Just as cold as the other ones. Here's a picture of what it might look like. There's an astronaut planting the American flag on the moon of Callisto. That's really cool. So again, there's the image showing those 4 moons of Jupiter relative to the size of Earth and our own moon. Saturn, the prettiest planet, aside from Earth. That's what it would look like if it was in our night sky at the same distance that our moon is. That would be amazing to look up and see those rings every night. Saturn is named after the Roman god of agriculture, farming, growing things. It's 9.6 AU from the sun, so 9.5 times as far from the sun as Earth is. Its rotation period is 10 hours and 33 minutes. It rotates very fast, faster than Earth. And it's bigger than us too, quite a bit bigger. So that thing's really moving. And it takes almost 30 years, Earth years, for it to orbit the sun. It has more moons than Jupiter that we know of right now, 82 moons. They're constantly in this race of who has more moons. So Saturn's rings are really, really wide. They're 127 kilometers wide. I put little parentheses there to put in how many miles that was, and I didn't have time to do that math. But they're very thin. They're only 20 meters thick. They're only 60 feet thick. That's not very thick at all. So if you were looking at them right at the edge, you might not even see them at all. So how do these rings form? They formed when comets and other objects got too close to Saturn and they broke apart. They broke into little pieces, and then they found those nice stable orbits. One of the rings is being constantly created by one of its moons, which has ice volcanoes, basically, that's shooting ice out into space, and that ice forms one of the outer rings. We're at a specific moment in the history of our solar system. If you go back 100 million years, Saturn probably doesn't have those rings, at least not like that. If you go 100 million years in the future, Saturn probably doesn't have those rings. We're at a very short period of time in terms of the time scale of the universe and of our solar system that we have these rings. So I feel pretty fortunate about that. Here's another picture of Saturn. This was taken from the far side of Saturn with the sun on the other side of it. So when the planet is backlit like that, you can see there's more rings than you're used to seeing from Saturn. These are the ones that we can see with the plain eye, without a lot of help. Look at these other ones. That's so cool. Pardon me as I take a sip. This is a look at Saturn's south pole. I did not expect to find a design of clouds on our planet or any others that looked like that. It's a hexagon. How does that happen? I want someone who studies weather and clouds and wind and stuff like that to figure out why does it do that and let us know. There probably are scientists that have theories and have stuff, but one of you could be a scientist, a weather scientist of other planets. That would be so cool. So Saturn has some incredible moons as well. Titan is one of the most fascinating ones. It looks very blurry, doesn't it? Well, that's because Titan has a very thick atmosphere, like Venus, similar to Venus. That, my friends, is an actual picture from the surface of the moon Titan. Those are real Titan rocks, real Titan atmosphere. It looks very foggy and hazy. Again, that's the thick atmosphere, that's the thick clouds. It's cold down there. It's negative 179 degrees Celsius. It's tidally locked with Saturn, and it orbits Saturn every 16 Earth days. Its gravity is kind of 1.38 Earth gravity, so you'd be very light on the surface of Titan. Let's see, do I have some more? I'm gonna cheat here really quick. Okay, I don't have more pictures of Titan, but here's the thing. We've had one spacecraft go land on Titan, and it got this picture and quite a bit more in the couple of hours that it survived on the surface. There's a mission being planned by NASA right now to launch in maybe 10, 15 years down the line, where they're going to send basically a helicopter over to Titan. It's got an atmosphere. The atmosphere is thick enough that you could take a little quadcopter, like a little drone, and fly it around. So there's some really cool ideas. This is Saturn's moon of Enceladus. This is, again, a watery, icy moon. You can see this is a real picture taken by a spacecraft near Enceladus, and you can see these things coming up from the surface. Those are ice volcanoes, ice geysers that Enceladus, like many of Jupiter's moons, is heated from the push and pull and squeezing and dragging effect that Saturn has on the moon, and that heats things up inside, and some of that heated water shoots out from the surface and out into space. Scientists would love to get a look at what's in the ocean, the liquid water ocean under the surface of Enceladus. But it's really hard to land on a moon that is, tens of millions of miles away and drill through 1 mile of ice. Luckily, Enceladus does us a favor. Enceladus is bringing its liquid ocean to us in space. There's a mission being planned where they'll take a spacecraft and it'll orbit Enceladus and it'll fly through these plumes of ice that are shooting up from the ice volcanoes. And it will be able to bring that stuff in and sample it and run tests on it and see, is there life? Is there life in the subterranean ocean of Enceladus? That piece of science will happen in your lifetime, in my lifetime, our lifetime. Be prepared. Here is what it might look like on the surface of Enceladus. This is an artist putting it together. And you can see here's these ice geysers shooting ice up into the sky. And you can see we're looking at the very edge of the ring. Very thin, and you can see the shadow of it down there. Okay, super small Enceladus is. It's 0.0113 Earth gravity. Not a lot of gravity at all. Uranus. Again, it looks very cloudy. It's a gas planet. It's pretty big. Gas planets are going to be that. That's what it would look like in our night sky if it was as far away from us as our moon. It's 50,724 kilometers in diameter. It's very cold. It's getting way out there. This thing is 19.2 AU. 19.2 astronomical units away from the sun. So it's really cold. It orbits kind of, it rotates kind of quick, 17 hours and 14 Earth minutes. And it takes 84 Earth years to orbit the sun. It's got 27 moons. And let's see if I have any other cool things about Uranus. Oh yeah, it's named after the Greek god of the sky, which makes sense. It looks like the color of our sky. This one, it spins on its side. So instead of spinning like this, instead of rotating like this, it rotates like this. It also spins backwards compared to all the other planets in the solar system, except for Venus. And scientists, the theory on why that is that when Uranus was mostly developed and it had figured out how it wanted to spin and all that stuff, it probably got hit by something really big, some big planet. Not as big as Uranus, but some big chunk hit it and kind of like knocked it sideways, and then it stuck there. And here's Neptune, the 8th planet. That's one of the best pictures we have of it. We don't have a lot of really super close observation of Neptune. The last mission that visited there was in the 1970s. There's a lot of talk right now about sending another mission to Uranus and Neptune to do more science, more observations. That's how big it would look in our night sky. And let's see, a little bit smaller than Uranus. Not a lot that I'm going to talk about this one. It's named after the Roman god of the sea, that deep dark blue color. And Neptune does have some faint rings around it, like Saturn and Jupiter. It's not visible to the naked eye, and we didn't even know that it was there until 1864. That's not too long ago. All right, we are going to talk about Pluto. Yes, we have 2 minutes. Good. I'm going to keep going here, even if we run out of time. So here's Pluto. Fun fact about Pluto, not a planet. That's a fact. I'm going to stay by that. But even though it's not technically a planet per the definition that we as a society have agreed upon, it is a fascinating object in our solar system. It's small. It's super cold. It is a long ways away from the sun. The closest it gets to our sun is 29.4 AU. That's a long ways away. And it goes even farther. It goes out to almost 50 AU. So its orbit is not this nice, clean, almost perfect circle like the rest of the planet. It's a big oval. It has 5 moons and has 0.063 gravity. If you were to go down there, stand on the surface and give it a little hop, you would just go for a while and slowly come back down. One of my favorite things, I know that there are people from Texas watching this webinar right now, and they would want me to point out to you that here's this heart-shaped kind of ice formation on the surface of Pluto right there. That heart-shaped formation is about the size of the state of Texas. So that's cool. Not a planet. All right, let's see. Okay, so I guess I did have a little bit of time at the end of this, more time than I thought. I'm going to talk really quickly about why Pluto is not a planet. As we did more research, more observation of the rest of our solar system, we started finding more objects like Pluto. It is, if you took Pluto and you took everything else that's in its orbit around the sun, all of its moons, all the other asteroids and stuff like that that we know are in Pluto's orbit around the Earth, and you compared the weight, Pluto weighs less than all that stuff combined. That's different from every other planet, right? If you take Earth and you compare it to the weight of the moon and everything else that's in Earth's orbit, there's asteroids and different things like that in our orbit around the sun. The Earth weighs more than all that stuff combined. Same with Jupiter, Mars, Saturn, Uranus, Neptune. Not Pluto. Pluto weighs less than all that other stuff combined. That's one of the main criteria, one of the main rules that they were looking at, because if we called Pluto a planet and we call everything else a planet with the same criteria as Pluto, we would have probably dozens of planets in our solar system. So they had to get more specific. They had to draw the line somewhere. Let me see if I hid some slides in here about, no, I didn't. Okay, well, here's the thing. There might be another planet out past Neptune, out past Pluto. They think it's about 10 times further from the sun than Pluto is, way out there. They think it's probably around the size of Uranus or Neptune. They think it's a gas planet, but it's really dark. It's really hard to see because there's just not a lot of sunlight out there. So they've looked at the orbits of the planets. They've looked at the orbits of different comets and stuff and different other small little planetoids like Pluto. And those orbits seem to indicate that there's some source of gravity about the same mass as Uranus or Neptune out there at this rough location. So now they're looking. There might not be. There might be some completely different, totally workable explanation that explains the observations that they've made. Or there's a planet 9. I like that. That sounds really cool. And if there's not, then that's okay. So, events at Delphian.org. If you have made a space helmet or part of one, it's in progress. I would love for you to send a photo of it to events@Delphian.org. I'll show it in one of the upcoming webinars that we do. And before I end off for the day, I will take one last look in the Q&A section here. After I end the broadcast, after I end the stream today, I'm going to stick around for a few minutes with the camera and mic off. And if you have some last final questions, I'll be able to see those and answer those. All right. Thank you, everyone, for joining me today. I will see you. It's on the schedule. I think it's Thursday. Maybe it's Friday. I think it's Thursday that we're doing the next one of these. And we're going to be talking more about our solar system and what's in here. We're going to talk about Planet 9. That's where my slides are. We'll talk about that and other really cool stuff that's in our solar system. All right. Bye, everyone.